My bad. I was muted. My apologies. Hello, everyone. Welcome to Global Hack Week. Specifically, welcome to the second part of this stream. We'll be talking about smart contract vulnerability detection. We'll be using Python, kind of a continuation of what we were working on last time. I'll kind of dive into what we were working on last time in just a little bit. As you can see, my code space has stopped since I was last push things. Code spaces stopped. Let's see. It looks like we have a few people in chat. Hello to you as well. I love to see hackers in the chat. As a reminder, if you have any questions throughout this stream, feel free to drop them in the chat. I'd love to answer them while we're working through vulnerability detection and learning more about how to enhance the security of your smart contracts. I'll answer them like as well as I can alongside the content, and I love to hear any feedback, any thoughts you have, especially with security related things. Not too much of what we'll be doing today is like actually coding through a project. We'll just be kind of looking for vulnerabilities and talking through the vulnerabilities themselves, the different issues, and kind of like what risks and outcomes those can lead to, in addition to using some of those Python tools. Looks like we have a hello from India. Love to see it. If there's any other hackers who are coming in from different places, I'd love to hear that as well. I think it's awesome to see how Global Hack Week can connect like-minded technologists all across the world. And I get to talk to people I would have never got to meet otherwise. Hello from Belize. Love to see it. Another hello from India. I love to see it. I'll get to see those keep coming in. But now we can kind of get started. I'll do a little bit of a recap of what we did last time before we dive into some more smart contract vulnerability detection and how to protect those smart contracts. Looks like we have a hello from Colorado as well. I'm calling in from Missouri, so it looks like we have people from all over. All right, let's restart the code space. If you're unfamiliar, code spaces is a pretty useful tool. With GitHub, I enjoy it because you're able to set up your environment very quickly. I don't run into as many path or version issues as I do running locally. And it's also very easy to integrate different extensions and push it to GitHub so that y'all are able to see it as well. It looks like CodeSpace is back up and running. As a reminder, if you have not checked in already, make sure to check in and register your attendance with MLH. This allows you to be eligible for any bonus swag. If you attend 5 different MLH streams, you're eligible to win bonus swag. And also it's a good way to allow us to see like which types of sessions y'all are interested in, so we can continue to make those types of sessions in the future. So this bit.ly link should redirect you to the MLH check-in link. And also here is the reference code or reference repo that we'll be working on today. I have things from part 1 as well as part 2 and a little bit of a background with like other links if you want to keep exploring this in the future. But I will send that out at the end as kind of a recap of what we did last time. So essentially went through a Slither tutorial and we were verifying the accuracy of whether or not Slither was detecting different vulnerabilities. We walked through some issues. We were debugging our Slither library. If you were here for part 1, you know that I was in the command line for a bit, tinkering around with things to make sure we could actually investigate those smart contracts. And then we walked through those examples, finding which vulnerabilities they had. So as you can see here, for our test file, we had severe vulnerabilities, and we found what the solution would be. And we kind of like walked through where in the code you would edit that. And here in the test 3 files, we found both severe vulnerabilities as well as medium vulnerabilities. Today, we'll be walking through a few commands that are a little bit more specific to target very, I guess, granular level things you'll be looking for in your smart contracts when you're trying to make them better. And these concepts can also be applied to Web 2 security as well, as you'll kind of see a lot of the concepts we're talking about, like unchecked transfer, array length, division before multiplication, strict equalities, that kind of thing. They can also be applied to Web 2. So what you are learning today, you can apply both in older technologies like Web 2 as well as Web 3. All right, so let's get started. I just want to make sure that everything is like kind of like up and running and we can start running commands. I want to go back and just like make sure everything's set up so we don't need to do any more debugging later on. So basically to run our commands, we just run slither and then we type in the directory with the test file. So we have test.solidity. All the contracts that we're running on are from the Ethereum network written in Solidity. If you're unfamiliar with Solidity, Solidity is a Web3 programming language. It's pretty similar to Java. So if you have experience with Java writing smart contracts in Solidity, will be not that foreign to you. Okay. Let's see. Is everything properly installed? No. Okay. So let's see what's going on. Is it... I'm going to make sure that the SolC version is all up and running properly. Okay. Just want to make sure this is all properly set up. SolC version. Okay, so it's running right. I remember. Okay, here we go. So SolC, if you're did not get a chance to tune in for our last stream, basically in order to run Slither, you'll need to change the version you're using of the Solidity compiler. So as you can see here up the top, there is the Pragma Solidity with version 0.6.0. And some of the other ones were in different versions. So as you can see here, we have 4.2. So I'm changing it here. And that I think we should be able to run our Slither test. This is the one that had all the import statements. So that's why we cannot run this one. I'm honestly just going to get rid of this test file. And then we can just focus on testing Solidity files that don't have all those dependencies, rather than installing an entire project. If we had more time, this was maybe a day-long stream or maybe a semester-long course, I would be more apt to bring in entire like 150 file directories. But for the purposes of today, I'm just going to rename these two. So we have test and test 2 now. And then this, we're just going to go back to part 1. I'm going to need to change this to test 2. All right. So let's run this again. Now we need 0.610. All right. SolC select 0.6.10. Oh, oops. Perfect. Unable to compile all targets. Oh, I see what happened. So up here, instead of doing SolC select use my version, I just did SolC the version. The person who asked which one did I delete, I deleted this the one that was test.sol originally, and then I changed test 2 to be just test, and then test 3 to be test 2. So just moving everything up, because the test.solidity file, I forgot from last time, had a ton of importing dependencies, and I just didn't want to have to deal with that added complexity for today. All right, so do SolC select, use 0.6.10, and then we should be able to run this. All right, perfect. So we're getting everything we were originally getting. Kind of as a quick recap, we're not going to go through all these errors this time. We did this in part 1. But if you are new today, basically Slither is a static detection tool. that's implemented in line with in the terminal using Python. Um, and you're able to go through and find both medium, high, and low level threats. Low level threats are typically just like syntax issues. They're not really going to cause any I guess like major hacks or things like that. There's not any major vulnerabilities with low level hacks. Um, but kind of like best practice is to fix that. A lot of times they're not quite deprecated yet, or maybe they are like recently deprecated and just like won't lead to any issues. But staying on top of that is important because then you don't get a ton of really old legacy code, essentially. Medium level threats can lead to malicious attackers coming in, but it's going to be like more of an advanced hack if they are getting into the system with a medium level vulnerability, and it tends to be a little bit easier to close, a little bit more difficult to attack. Sometimes these are also dependency or deprecation issues, and then high level threats can sometimes be used in like more complex level malicious attacks, but they don't need to be as complex essentially to get into your application. And a lot of times the reason they are called high level threats is because the nature of the particular vulnerability can lead to a high level of loss, whether that be sensitive information being leaked or lots of money being stolen or redirected. When you either have it and you obviously don't want millions of dollars stolen out of whatever account, or if you don't have it and it just continually withdrawing funds, which is something we talked about last time, is a particular vulnerability where they can just like repeatedly withdraw money before the original transaction ends, even if that money doesn't exist in the account in the first place, leaving someone like majorly in the negative, which is not good. Especially for accounts that are, I guess, this is a little bit more geared towards Web 2, but for accounts that are approved for, I guess, like a larger level of loss, just because of like the amount of money they're like used to dealing with. Whereas in Web3 with like decentralized applications, it wouldn't be as large, but still a pretty large loss is possible. And it's more difficult to get that back because these things aren't FDIC insured as their cryptocurrency. That's kind of my little side side tangent. Whatever. I hope that was helpful. Oh, it looks like we have a question. High, medium color scheme is red to green. Yes. So high for high alert or high I'm forgetting the word. Basically, high vulnerability is high frequency, high detection is going to be red, and the low or like easy or kind of like dependency level issues are going to be in green. And then there isn't any medium level dependencies on this particular one. I think there are on the test2 file. Those are going to be in orange color, I believe. I don't remember exactly which shade off the top of my head. We can just honestly run the command for test2, but before that, we'll need to switch the Solci version. So Solci select use, I think it's 4.2. Yes. Use. And then I'm going to run the test2 file to show you all what the medium level alerts look like. Yes, as you can see, these are this orange color. So it's red, orange, green to kind of show you the differences. And also, as you can see, when you're running into the same issue multiple times in your file, most of the times, it's going to have all the reentrancies or all of the exact same type of issues in that smart contract grouped together. So here you can see contract locking ether found, contract locking ether found. It's found multiple times, but they're all in the same place. So once you know that you have that sort of issue in your smart contract, you're able to find all of the instances of it along with this very helpful reference. So if I click command and click on this, it's probably just control on Windows. It brings you to the Slither wiki. The Slither wiki is very long. There's like a lot of a lot of different issues. I probably shouldn't have done that because it's gonna. Okay, I can just refresh, and it brings me back to the shortcutted page, and you have the configuration of like how it's being checked using the Slither static, how severe the problem is, and how high the confidence is in that particular issue. I think it's usually a high confidence for medium to high severity. And then it gives you a quick description of what's going on as well as the exploit scenario. And when you're going through all of these issues, all of these vulnerabilities you're detecting, you're able to solve them all at the same time because you have the contract locking ether found in both places. And once you figure out what the solution is, you can implement that all at once versus finding one and then going on to solve a different issue and then maybe not being as familiar with it, or you need to hunt a little bit longer or refamiliarize yourself with the issue. So I really like this feature, especially here. You see the reentry occurring. Let's see, I think it's five times. That's like pretty often. So you're able to find which specific code block it's happening in, and then fix it all at once. So that is how like the basic Slither command works. I think we'll take a few more smart contracts and test it out using the Slither commands now that we got all the errors figured out. But after that, I have a few Slither commands that are a little bit more directed towards like when you're trying to find particular things in your smart contract. Maybe like we talked about in last session, one thing that you want to do when you're thinking about security in your applications is asking a lot of questions and kind of engineering things ahead of time. Kind of similar to test-driven development. I don't know if it's called security-driven development off the top of my head, but essentially asking those questions of, I'm familiar with this particular exploit and with like the nature of whatever application or contract that I'm building. I know that I want to kind of like proactively look out for this aspect of security. So those particular commands will allow you to like target, but I'll show you in a little bit, target these specific issues. If, for example, you're maybe really concerned about reentry in your application, or you're really concerned about proper proposal. I'm just like looking at the first vulnerabilities that I'm finding on here. But the commands I'll show you in a little bit will allow you to kind of like more directly look for issues. But before we dive into kind of targeting those specific issues, I want to get back to essentially just pulling in a few more contracts, and we can look at kind of a wider variety of these issues and the kind of like bulk Slither commands like we see right here. But like there's a ton of Slither commands. So I'm just going to kind of scroll down. If you're unfamiliar, last time we went into this pretty cool repository called Scraw ID. It uses a bunch of different vulnerability detection tools to compile issues in published smart contracts. And then I'm going to go over here to our Etherscan smart contract search. It's part of the developer tools on Etherscan, which is an Ethereum website. Looks like we have no matching smart contracts. All right. Maybe this one is not published. Let's go on to the next one. Let's see what's going on here. No smart. Okay, let's see. Smart contract search. Interesting. Let me try with the first few that we used earlier and see if I'm going to be unknowingly on the wrong page or something. Okay, what's going on here? Developers. Oh, am I... What's your addresses? Let me go back a few pages. Okay. Smart contract search. Okay, well, we're waiting for this to load. It looks like we have a question. Has anyone tried to make the voting system using Next.js? I think this is in reference to another one of the coaches' streams, the Next.js voting system. I don't know all the details of that, but I have not personally tried that. I think you'll probably find a little bit more information on those previous recordings or those streams if there's any more Next.js streams coming up. I think this other hacker just following along, I don't know, with the Next.js. All right. I don't know what's going on with Etherscan right now. I'm going to just pull this up. All right, so we have our smart contract search. I'm just going to do a creation date if we're running into issues. Let me do just June 12th, maybe. Okay, we're getting a contract. Okay, so it's maybe just the address I was putting in aren't popping. They're not like bringing anything up. Here we go. Okay, our search tool is working again. All right, so here we have another contract. It doesn't look like this one has a ton of dependencies, no import statements I'm seeing. So I'm going to bring this over to our Slither test files. Have test3.solidity, bring it into the test files. Here we go. I'm going to make test 4 just so we can work through a few more of these contracts. This one looks like it has a lot more issues than the other ones we were looking at. And I think this one has a solid number of issues as well, because both the ones we looked at earlier didn't have all that many issues with, it was pulling up, it had like a few severe issues, but not all that many. So I essentially just want to find some more where there's just more information that's they're spitting back out. Let's do this one maybe. No matching files. Let's see. We can again. Okay. Let's look into this a little bit more. All right. So again, I'm looking for something that has, this one looks like a good number of Slither issues. Okay, again. Just gonna search 6. Okay, interesting. There can't be no smart contracts with 6. I'm just gonna move on and work on just test 3, and we can go on to target spotting things after, I guess, we do smart contract 3. So looking into smart contract 3, we are using, is this the exact same? Yep. Okay, never mind. We will not be using this for 3 because it's the same smart contract. Okay, which which is the address for this. That's the same one. Etherscan seems to be a little bit slow today. Okay. Okay, this one looks like a new one. I'm not quite sure what's happening with the addresses, but we're getting another one. Okay, here we go. So basically, not too sure what's going on with Etherscan, but I'm bringing in a new smart contract that we can test out with Slither. So we will do Slither test3.solidity. Okay, here we go. So there were 17 different contracts in that file, and we found 92 different warnings. So as I talked about earlier, there's all of these kind of like low-level threats, all the stuff in green. We're not going to get into that because there seems to be a lot of medium-level threats, and then it looks like just one high-level threat. The high-level threat is detector documentation with unchecked transfer. This one we talked about. We talked about this one last time. If you weren't there last time, essentially it's where we're not checking who the value is being, or who the like currency is being transferred to. In this case, and in the case of like this being exploited, we could get basically lots of deposits from an account into a non-approved account, causing for the loss of funds, which is not good. We're getting some divide before multiply. We talked about that last time. There seems to be a relatively similar contract to test 2. Here we are getting some re-entrancy. We talked about re-entrancy last time. That's the one where they can have essentially an infinite loop where they're continually taking money out without before the initial operation even closes. And here is the unused return. I don't think we talked about this one in the last session. Unused return is a medium level severity with also medium level confidence. So the description, the return value of an external call is not stored in a local or a state variable. So the contract, my contract, calls the add function of safe math, but does not store the result in A. As a result, the computation has no effect. Okay, so essentially what this is doing is that like, nothing is going to end up being returned, and like the function won't be able to execute properly how it's intending to be like executed, because we aren't assigning A to anything. So we can't actually add B to A if we're not creating it to like a global or a local variable. So that is medium level for that one. It looks like that is all for the medium level. I'm going to look at some questions before we go into targeting these a little bit more specifically. Someone asked, why do we have such errors when these can be tested for easily? That's a great question. I think that most of it comes down to developers are not looking at things with a security mindset. And also, a lot of these contracts that we are testing for are a little bit older. So if you look at some of these, they're from 2020, a little bit older when smart contracts were first being developed. And I guess like first becoming like a little bit more popular. And also, like a lot of developers are just kind of like executing things, and if it works, regardless of whether or not we have these vulnerabilities, they're still executing, even if these vulnerabilities are present. They can still run. It's just like it's not great that they're running because they have these vulnerabilities. So basically, like TDLR, people not having like that much of a focus on security. And just like not thinking about it ahead of time. But I think it's like similar to kind of like why we see these errors and security issues with Web 2 programs as well, just because people aren't thinking about them or testing for them, even if they can be tested for relatively easily. Okay, so now that we've gone through a few more of the Slither commands, a few more like iterations of Slither, I'm going to go on to basically analyzing different different Solidity files a little bit more in depth. So like I talked about, like if you are looking through an application or if you're looking through a smart contract and you know for a fact that certain aspects of the contract are more vulnerable, or you are proactively looking ahead for these vulnerabilities, you might be looking for specific aspects of your smart contract and that runtime. These different commands will help you. There are like a number of different Slither subcommands. If you remember from last time, I should be able to run in the terminal. Okay, here we go. If I just run Slither, if I spell Slither correctly, you can see all of these subcommands. We'll just be going into a few of them. So you can see here, if you want to connect it with Etherscan, you're able to do that as well if you have an API. And there's different particular commands you can run to compile things or to look out for specific aspects with the flag. If you want to look into that more, just literally run the Slither command. But in this case, what we're going to do is run through a few of these commands to find more information on our smart contract. So here we have tokens. This is going to show you all the tokens that are represented in code, or if they're not represented in the code, it will tell you that. There's variables, functions, contracts. I think that the first one I want to run is the contract, even if it's a little bit out of order. Like we said in the last one, the last version, or the last code file, the last Solidity file we were running, there were 17 contracts in there, and I'm curious to see how well this command is accurate in this case, or if there's maybe any configurations we need to do. So we're going to do Slither, and then I'm going to go to Slither test files, test 3, and then the flag I'm going to do after that is just going to be -- contracts. Usage, unrecognized argument, contracts. Interesting. Oh. Let's see what's going on. Unrecognized argument contracts. Maybe. No, that's. All right, let's look at this a little bit more. So it's not recognizing the contracts argument. Let's see if Copilot has any idea. If a Python library is giving me the error unrecognized argument, how do I find the recognized right argument? Okay, I think we can. So it's basically just telling us to read the documentation. It's kind of funny. Let's try tokens maybe and see if it's just the contracts. Interesting. My Slither analyzer has been installed. Looks like everything's already installed. Let's look at the documentation. All right. Okay. Slither Python flags. Okay. Okay. I'll try a few of these other ones, and if not, we can just move on to some some of the common exploits that have happened with, or the common vulnerabilities that Slither has detected and could have stopped attacks with. I'm going to try this also on a few other. Okay. Okay. So it's running properly. Interesting. Let me just run Slither and see if maybe the flags are just outdated. Okay. So I guess there are just a few, like the flags have just been updated. I'll show you, I guess, one of those, and then we can move on to common vulnerabilities. Okay. So I'm going to let's exclude dependencies. All right. Looks like there weren't any dependency issues to begin with. We're getting the same number of results. So let's see what else we can do with the flags. Do checklist. It should be interesting. This one should provide a checklist in MD based off of the results. Oh, here it is. That's pretty cool. So it is returning all of the different items that are going on and everything we'd need to fix for this application. Yes. Cool. This is a pretty cool item, and it provides more information on all of these. Okay. Interesting. All right. So since these specific flags that I was looking to use seem to be deprecated or something, I guess we can try one more go around. All right. It looks like it's a common issue. It looks like this exists on Slither versions 8 and above. Okay. Okay. Interesting. Anyways, we're gonna move on to look at not these. We can get rid of this. Here we go. Slither trophies and Slither Reft. We talked about this a little bit in the last part of this streaming series. But essentially, what Slither trophies and Slither Reft are a part of the Slither like documentation, and it shows different vulnerabilities that it detected, that Slither detected, and like what project it was on. And I think this is interesting because it can show you like what real life consequences can come from not testing your application, and how like you can save yourself a lot of headache if you do test. So here is parody. Looks like it's this very long report. So the most severe issues may lead to theft of ethers and unauthorized deletion of wallets, which is not good. That can lead to like a lot of loss of money. Yeah, and validation. Some of the other reported issues: more configuration, cryptography, data validation, memory management. Um, Here's the solidity stuff. The solidity is what Slither would be detecting to begin with. The Rust code was like they found vulnerabilities in that using other methods. So we're just going to focus on this because there's going to be a lot of reports for all of these. They do a little bit like more formal write-ups for case studies like this, but we're not going to be reading the entire case study, of course. Unit testing. So this is kind of like tying back to what I said last time, because the code base would benefit from more detailed documentation and unit testing. Like I said earlier, a good way to kind of like prevent these issues from happening in the first place with your smart contracts, your decentralized apps, is to have test-driven development on just kind of like thinking about the security issues ahead of time. And running those tests is a good way to find the security. Like we had a question about earlier, why we have these errors if they can be tested for so easily, if they can be found. And like I had said, a lot of people just aren't running the test. So you're able to avoid them if you're running the test and like you're thinking about that, like what could go wrong and what you're looking to avoid kind of like from the get-go, and you're testing for that throughout your entire development process. I mean, as you can see here, we're finding errors when we do not have that test-driven development. Some of the other issues we are seeing here are restructuring content, contract inheritance, and proper use of interface would benefit several smart contracts, and a effort to homogenize the code base by adopting a single coding standard on a single Solidity version. So this looks like it's kind of like the Swiss cheese or like very deprecated and uneven code base is like the issue they had in this parity project. So that's another thing we're talking about. How like last time we found a few smart contracts that would have like 150 files in like as a part of their smart contract, which in some instances like might make sense. But if it's possible to avoid that, I think that it's a good idea, because with a lot of dependencies comes a lot more risk. And if you don't understand everything that your smart contract is depending on, you could run into like a lot of issues, a lot of vulnerabilities that could be more difficult to solve if you just don't understand them from the get-go, or maybe just decide to code something out a little bit more by hand versus like using a imported library, imported file. But that's interesting to see. And it says here they've included Slither in their report. The validate code changes. Okay, and they're using Slither to kind of like test for these errors in like their development and like editing process, which is pretty cool that they're using these tools as a part of their test-driven development process for the longer term. All right, so we have a comment here. As a general rule, a larger dependency chain can lead to more complexity and more security risk. I completely agree. And kind of like you were saying as well, this is kind of like across a lot of languages and like a lot of technologies. A lot of these security issues are not dissimilar to what we're seeing in Web 2. You would think with Web 3, a lot of like the points and the ideas behind Web 3 is like a newer, more modernized version of the web. Want to decentralize things in Web 3, of course. But if you don't bring in, I guess, like new ideas and new, I guess, like standards of development, you're going to run into like a lot of the same issues. So similarly, if you have like a website and Web 2 built on like an NPM, like you're using NPM and like a lot of JavaScript libraries, if you're not consistently updating it and like making sure that your application isn't getting deprecated, then you can run into like a lot of issues. And it can get like increasingly confusing because I've always found that the simpler an application is, even if like it's like a like trying to do complex operations or the overall goal of the application is very complex, if you have too many files, too much going on, it gets very difficult to debug once anything goes wrong. So even if it's going to take more time and more bandwidth to kind of figure out everything and like code it out from scratch or to fully understand everything that's going on, it's going to save you a lot of like time and headache in the future because you're not running into all these like dependency issues, all like the complexity that comes along with them. You may or may not understand, or things get deprecated and you don't know because like you can't possibly have a firm grasp on when everything gets deprecated or when it goes out of like when it's like no longer relevant in your code base if you have hundreds to thousands of files. All right, so back to looking at these reviews. As smart contracts, we're seeing the different components. It looks like they are kind of like walking through the application a little bit more. They're looking into the smart contracts. And they looked for common solidity flaws that Slither is looking for. In addition to, they looked for more nuanced flaws. Like we talked about last time, Slither isn't going to detect all of the different vulnerabilities, all the different errors in your application. So that's good that they're going through your application and looking for more nuanced and kind of like more specific errors that you might see. And then they also mentioned that because of like time constraints that they didn't assess contracts for denial of service due to high gas consumption. So if like you're not always going to be able to analyze for everything, but if you know you have a blind spot in your application, whether that be the security of Web 2 or Web 3, it is a good idea to just like make a note of it. So like moving forward, you're able to remember that you didn't check for that or you didn't like dive into that particular vulnerability or testing that as thoroughly as you wanted to. So you know where you can like kind of first know where to check if you run into issues in the future, because if you're not as thoroughly testing it, the odds that that could be the issue might be higher. So noting that down for future iterations of test-driven development or like just kind of debugging and problem solving when you do run into malicious attacks. I think that would be a good idea. Project dashboard, Rust recommendations. We're not talking about Rust. Smart contracts here, like they have like the short-term recommendations based off of what they were finding in the Slither library. And it looks like they also have some like long-term ideas. These are ones that are going to take longer term. I would guess that most of the issues under the short term are the medium to high impact issues that we were like talking about in red and orange earlier, whereas the longer terms are like become more familiar with solidity documentation, making sure that things are not deprecated, kind of following best practices. While they are like they're not like like the top priority or short-term goals, they are kind of like on the list of things I want to do, so they're not running into these security issues down the road. We have the Rust findings. It's a pretty long write-up. All right, some more Rust. I think. Yeah, Rust findings. Let's see if they have solidity findings. If not, we may just move on to another review. Yes. All right. So it looks like this is loading. I think we kind of covered the gist of the parity one with different vulnerabilities. I think I will look into one more before we look into where Slither could have prevented some issues. But in the meantime, I need to grab some more water so I don't lose my voice before we get into talking more about the stream. So I'm going to have a brief little intermission, grab some water, stretch, use the restroom if you need to. We'll be back in just a few minutes to dive more into Slither vulnerabilities and different projects, like where those are applied. So I'll see y'all in a few minutes. All right, we are back. I hope you were able to grab some water or take a little break as needed. We're going to dive back into looking at a new um, trophy, a new area where Slither was able to detect a vulnerability in a smart contract. So it looks like Atomic Loans had a good amount. This is from December or July 2020. So, oh, this looks to be like a pretty expansive application. Let's go. Excuse me. I just sneezed. I'm gonna go back to the trophies. We can find some more Slither side information. And then we can walk through the website. All right, so for atomic loans, it found an uninitialized state variable, shadowing, and reentrancy. And it looks like atomic loans is now called quant stamp. Interesting. So here are the public security assessments of projects secured by quant stamp. Oh, okay. Here we go. Atomic loans. So it looks like quant stamp is a Web3 security auditing system. Yes, smart contract security. That's exactly what they do. Interesting. Here we have their report. So we have their, they've got like a definition of everything, which is nice to know. The goals. All right. So it looks like there was not any high, or high, medium, or low risk issue, or there was 2 low risk issues, some informational risk issues and undetermined risk issues. Informational is relevant to security best practices. Okay. And then 2 of the risks were undetermined, so they could be either high or low risk, which is interesting. All right. No critical security issues. Shows which different issues are found. I want to match the issues they're finding with what's on this Slither documentation. So we have uninitialized state variable. All right, so that is for the code does not adhere to the checks effects interaction pattern. Input validation, I think that matches up. Okay, no, okay, so we have reentrancy as well. Cool. They have, oh, here's the reentrancy. This should be probably listed as a high risk issue for the gas and for loop issue. We talked about that last time, and that can lead to like a lot of missing funds being taken. All right, and here we have the code documentation. They have it updates on all the fixed, and it shows information on like the action that needs to be taken for each of the code, like each line of code. And it's sort of by best practices. This seems to be a pretty cool project, the quant stamp. Nice. And then this looks like the output from Slither, just put in here, and then whenever things we're saying should be doing different things. Basically, that is coming into like they're just checking them off as different action items that have been completed to fix the solution. And then the code coverage. Okay. So we're seeing what percentage of the statements are being covered by contracts. Okay. Cool. This is a nice report. As you can see, the reporting for the different issues and vulnerabilities varies. This is like a more, I guess, like overall, I guess, like problem solution focused report, whereas the one last time seemed to be a little bit more academic and they had a little bit more verbiage about all of the issues that they were running into, which is interesting to kind of see. All right. Let's move down to the Slither Wrecked. So these are different real life Web3 issues, like security incidents that could have been prevented if they had used Slither. So this is just kind of like a reminder of like what can happen if you don't use vulnerability detection, if you don't have like test-driven security development in your smart contracts. So here we have DForce with the re-entrancy issue with $25 million lost. Luckily, they were able to recover that money, but as you can see, only two of these security incidences had any value recovered. It looks like the full 25 million was recovered for DForce, and this one with ForceDAO, 9.6 million of the 10 million was recovered, so most, but not all of it. The re-entrancy is occurring multiple times here. So, like as we talked about on that last report we went through, where it talked about re-entrancy as kind of like an undetermined risk, it should really be a high risk because of how much value you can lose when that happens. So I'm curious to see what the hack report says. So this looks to be like a Medium article. I hope that I haven't hit my I don't think I've hit my Medium quota, or this isn't paywall blocked. The DeFi platform Uniswap was attacked by a hacker using a re-entrant entry vulnerability. And then 24 hours later, a similar attack occurred on lendf.me. Let's see if that's listed. That is listed here. Okay. It says that they used, okay, incorrect self-transfer. We talked about that one too. The main logic behind these two incidents is the incompatibility between ERC 777 and those DeFi smart contracts, which might be misused to utterly hijack a normal transaction and perform additional illicit operations. Like we talked about when we were going through different vulnerabilities we were finding in our smart contracts. The re-entrancy is a big thing because you're not even really able to detect the amount of transactions happening until like it's kind of too late, because it's happening all before the initial original intended transaction has completed, because there is that re-entrancy before that has basically ceased. So you're not quite seeing that end, but you're seeing that re-entrancy happening. And like specifically in the lendf, I don't know. The transfer vulnerability. Basically, this is like when what happened in this particular case is that the funds were being transferred because there wasn't protection on who like the funds or items can be transferred to. And it looks like there was $8 million lost that was not recovered in this particular instance. And it looks like, I don't know if it was the same hacker in both of these instances, but it was pretty close together. So here it goes on to talk about the attacker exploits the vulnerability to drain the liquidity pool, while in the second attack, the attacker makes use of it to increase the, okay, so it's increasing the internal amount of the attacker's collateral so that um, the attacker can borrow all the assets at a value of $25 million. Okay. And then the ERC777 token that we talked about earlier that was incompatible that led to the security issue is a community established token standard with advanced features for different scenarios. But the advanced features weren't compatible with different DeFi situations. So this is kind of what I was talking about is making sure that whatever libraries or dependencies you're using, you understand and are, I guess, engineering potential malicious attacks or potential security flaws. I always think about whenever I'm building out an application, not only do I want to ask a lot of questions about the functionality and how does this work for the user, but also poke potential holes into my project of how does this work? How could this go wrong? I can see this specific thing going wrong. How would that happen? How would we fix that? Are there any similar instances where that could also be occurring with a similar vulnerability? In this particular hack case, there were two hacks occurring within 24 hours of each other. They had different outcomes, but they were related to the same incompatibility in the ERC 777 token. So going back down here, so it led to reentrancy. Other token standards, ERC 1155 have been similarly designed to have a callback function. The manual review said that indicates that it does follow the standard in these DeFi platforms. Okay. The vulnerability lies in the internal logic to call tokens to send. Okay, so it was the tokens verifying issue. So that's where that vulnerability is lying in the source code that's relying on this, which in some instances might make sense if it's not a sending variable. But if it's not a sending function, but if it is a sending function, sending contract, you need to have that verified. In particular, is used to retrieve from the registered implementer if this particular function takes two parameters from and tokens sender interface. Then when this was exploited, the first argument is the attacker. And then the second is a consultant. And then later on, whenever the tokens to send function, it allows the attacker to hijack by injecting multiple malicious code for execution into the functions. They're adding in their own code because it's not fully protected. All right. So selling the same batch of tokens multiple times. This is the reentrancy issue we were talking about earlier. It seems to me that the second malicious attack was a combination of the reentrancy happening with a lack of validation of who you're sending the tokens to. Okay. Okay. So basically what's happening in the second instance that's different from the first, as if they are artificially increasing the collateral amount without actually depositing the amount. And then they're able to subtract based off of a artificial or incorrect amount. So leading to extra losses because they're able to inject things. Cool. So here are some like mitigation. What we're talking about with the attack is the checks effects interaction design pattern. So this was where they would call the transfer in after saving the user updates of the token balance. So there's no way the hacker can reset updates with the withdrawal call. So because we're updating that before we're transferring funds out, each and every single time, you're not able to kind of like add those injections in a way that would make sense and actually execute this code. But because of the token, you need to prevent reentrancy in all of the trading functions. So they can't like add this function into a supply along the way. So, and also the article kind of shouts out like you might need to like re-look at your token standards and might need to change them based on the particular functions of your DeFi app and like what assets you need to protect, which is extra important in decentralized finance. And before there is the protection that you have in Web 2 and I guess like more traditional financial institutions. Like with traditional banking and like Web 2, you would have things like in the US we have like FDIC insured accounts if it's like just like a normal like savings or checkings account, to where if there are malicious attackers, you have that protection from the federal government, at least in the US, to get back your money if there's hackers or other bank-related issues, but that the same protections don't exist in decentralized finance, which there are pros and cons to DeFi versus traditional finance, but that's a definite con, I feel, for decentralized finance. All right. So as is like pretty obvious, a hack like this is a big blow to the decentralized finance community, as I was just talking about. The assets is like a big amount of loss. Here is the amount, and in Ethereum or I think it's within Ethereum versus USD, and the percentage of these different currencies. So yeah, I think that's interesting to look at, kind of like multiple of those going on all at once. I'm not going to go through every single one of the wrecked incidents. I think that those two, as a reminder, that article is going into DForce, and the second one, the Lend one, those are different security incidents that Slither could have prevented. So I think that gives us like a pretty good reason to make sure that you're using test-driven development and looking into security issues during your development process, whether that be in Web 2 or Web 3, and why smart contracts are particularly important to find those vulnerabilities within, due to like the sensitive nature of everything and the fact that it is decentralized. Okay, so that is all we're going to go through today. We went through a lot of different Slither situations. We went through different areas where Slither has been super helpful, areas where Slither could have helped, but it was too late because the vulnerabilities had already been exploited. We went through a few more smart contracts. We looked into the different flags you could use within Slither. I will be pushing we made a few slight adjustments to the code space throughout. The code space stopped because I was talking so long in the GitHub repository. Starting back up again. I'll be pushing that to the repo if you'd like to look at anything we talked about today, access any of the links, take a look at them for yourselves, maybe integrate Slither a little bit more thoroughly into your smart contracts or your project. You'll be able to find that at the reference code bit.ly link. So I will share this in the chat. If you're, it's bit.ly, not itly, my bad. Here is the correct link. I'm going to push the few changes that we made today. So we have part 2. Those are going to be going up into this GitHub repository. If anyone has any questions, now's the time to drop them in the chat. I'd love to talk a little bit more about any security-related questions you have. I always find security to be very interesting, whether that be in new technologies like Web3, smart contracts, or in Web2. I love kind of like that combination of technical issues with kind of like the social issues and like the current events that all goes along with it. As you can see, there was like a lot of there's a lot of incidents in security and vulnerability detection that are interesting to talk about. So I will give y'all a few minutes if you'd like to drop any questions in the chat. And also, as a reminder, if you haven't already, make sure you register or check in with MLH for this part 2 of this workshop stream. It'll just be at the bit.ly/SCVD2, and that'll redirect you to register your attendance. So again, I'm going to give it a few minutes to allow you to ask any questions you might have about Slither, vulnerability detection, or anything we talked about today. And if you'd like to kind of continue working on your own or implementing this into your smart contracts, you'd be able to do that with the resources that I provided that we looked through throughout these 2 streams. All right, it doesn't look like we have any more questions. Thank you to everyone who tuned in for the second part of smart contract detection. It looks like we have a question. There are so many projects. Do we form teams to do them, or do them all alone? Too late for a team now. I think, are you talking about in reference to the Global Hack Week challenges, or the projects themselves? I guess like the different large smart contracts that we went through in this specific workshop. Oh, for the challenges. It is a bit late, I think, probably for teams now, because you can still submit challenges for Global Hack Week. For the more advanced ones, I think you can. Let me look into what it says in the dev post. I'm not super familiar with all the ins and outs are the challenges. Okay. Yes, a lot of them are simple for like following the GitHub Copilot tutorial or like signing up for whatever email list, but for like the more complex ones, it would take a lot more effort. It might be helpful to have a team. Let's see. It does not say, I'm not seeing anything about teams on the dev post. Look at the FAQ really quick so I can get this question answered for you. It doesn't say. I would think that would mean yes, but I would I'll send a message to the full-time team and see what they say, and get back to y'all in the Discord about the challenges. But I don't know. Yeah. And as far as hackathons, this sounds great. I'm glad you're interested in attending MLH hackathons. Love to hear that. All MLH hackathons are like collaborative and you're working on teams. I just don't know specifically for the challenges at Global Hack Week if those can be team endeavors. But thanks for the questions. Glad to help you better understand everything that's going on and get more involved in the hacker community, learn more throughout this week. But yeah, I will ask about team and see if we can figure that out before next Global Hack Week. As far as everyone else, thank you so much for tuning in to part 2. I hope you were able to learn something about security or vulnerability detection or just Slither in general. I enjoyed talking to y'all over the chat, and I hope you have a great rest of your evening, morning, afternoon, whatever time it is, and wherever you are in the world, and have a great rest of your Global Hack Week. Happy hacking, everyone. Thank you so much.